Hey guys, so today we'll be looking at Leetcode 3709 Design Exam Scores Tracker. So this was recently asked in the Biweekly contest. Okay, so we'll be looking at how we can approach this problem. Okay, so let's quickly go through the problem statement. Alice frequently takes exams and wants to track her scores and calculate total scores over a specific time periods. Okay, so we need to design void record and total scores. Okay, so record, it will, Alice takes a new exam at time and achieves a score. Okay, so it would be given time and score, and at time the corresponding score will be the score. Okay, so and total score, start time and end time, returns an integer that represents total score of all exams taken by Alice between start time and end time. Okay, so we need to give the total score between start time and end time. Okay, and calls to records will be made with strictly increasing time. Okay, so this will always be in ascending order. Okay, so let's say my record was 2,5. Okay, so the next call will always be like, the time will always be greater. It will be 3 or 4 or something greater. Okay, it can be something like 1,2. Okay, because time is less than the previous. Okay, so that would not occur because it is made clear in the question that it will be in strictly increasing order. Okay, so we just need to give the total score between start time and end time. Okay, seems like a easy problem, and time and score will be in the range of 10 power 9 and at most 10 power 5 calls will be made in total. Okay, so you can see the record will always be in increasing order, so we can of course do a binary search. So let's say I'm not taking the examples which are given to us. So let's say if the record was 1,2, so at time 1 the score was 2. Okay, and similarly 2, 3 and 4, 5. Okay, so what we can do is we can store them in a vector of pair, because time is already sorted. Okay, so we can store them in a vector of record, in a vector of pair, and we can do a binary search for the start time. Okay, so if we do a lower bound, let's say I was asked between 2 and 4. Okay, so I can do a, this was my start and this was my end. So what I can do is I can do a lower bound on this vector for 2. Okay, so I'll have this index, and I'll go till the end time, and I can get the entire sum. Okay, so this is the brute force approach, because you can see 10 power 5 calls will be made, and time and score are in the range of 10 power 9. Okay, so 10 power 5 and 10 power 9. Okay, it will of course give you a TLE. Okay, so we need to think of a better approach. Okay, so of course we are going to use binary search, but we are going to just optimize it a bit. You can see, right, with the help of lower bound we were able to get the start index, and similarly if we can do some sort of optimization with the end time as well, and if you could get them in the range, let's say in 2 operations, then we would need not traverse the entire length between start time and end time. We could just get them in a constant time, and 10 power 5 calls will be made, so it will pass the test cases. Okay, so what we are going to do is, so how can you get the total score in constant time? Okay, so we would need some kind of hashing or prefix sum for that. Okay, so what I'm going to do is since our time is already started, I'm gonna take two arrays, okay, time and score. Okay, so at time 1 my score was 2, okay, and at time 2 my score was 3. So what I'm going to do is I'm going to maintain a prefix sum of scores. Okay, so if someone were to ask me what is the total score at 1, okay, so I can simply tell 2. For 2 it would be 5 because current is 3 and previous was 2. Okay, so it will be total of 5. Okay, similarly for 4 it is 5, so it was 3, it will be 10. Okay, so if you were to ask me the scores between 2 to 4, what I can do is I can go at score 2, it is 5. Okay, so this is the entire area that I'm going to cover. Okay, and my end time is 4, so this is the entire area that I'm going to cover. So I'm interested in just this area, right? So what I can do is I can subtract from this. From 10 I can subtract 2 because 10 is like the total score and the okay, so this is the entire score and I just need to subtract this part. Okay, so I can just subtract one index behind my start. Okay, so what I can do is score of end, okay, minus score of start minus 1. Okay, this is of course if start is greater than 0. Okay, otherwise this wouldn't make sense. Okay, so this is what we are going to do. You can see, right, it is done in the constant space, constant time. So if 10 power 5 calls were to be made, then we can simply we would still be able to pass the test cases for this. Okay, so yeah, that is what we are going to do. We're going to maintain a prefix of scores, and we are going to maintain separate vectors for time and score, and we are going to take the prefix sum for the scores. Okay, and whatever start time and end time is given to us, we can simply do this formula and we can return the answer. Okay, so let's quickly look at the code and things will be much more clear. Okay, so let's just quickly look at the code. So I've taken two separate arrays to store time and score. Okay, so this will score our time and this will store the scores. Okay, so coming to the record function, so I'm just going to insert time and scores into the arrays, and if it is the first element, okay, let's say my time is 1 and my score is 2, my time is 2 and score is 3. Okay, so first I'm going to insert these both. Okay, coming to this, okay, I'm just going to insert it, and if it's just my first element, then there is no previous element, right? So there is no need to add the previous score, so I'm just going to return from here. But if it is not, okay, let's say if it was the second element, then I need to add the previous score to it. Okay, so that is what I'm going to do over here. Okay, so if it is not the first element, then I'm just going to add the previous score. Okay, so if anyone were to ask you at time t what is the total score, you would be able to give it to them. Okay, so coming to the total scores. Okay, so I have used a combination of lower bound and upper bound here, but I think you can do it both using lower bound and both using upper bound as well. It just depends upon the implementation and the cases that you are good at handling. So I'll give you my thought process of using upper bound for the end time and lower bound for the start time. Okay, so let's say if my time was okay. So this will all be specific to just the times, and the scores we'll see how we are going to handle scores, but the lower bound and upper bound functions are going to be on time, because it is the one which is sorted. Okay, so let's say if my time was this, okay, 1 3 and 5, and if I were to do a lower bound, okay, so let's say if my start time was 2 and my end time was, let's say, 4. Okay, so if I were to do a lower bound on 4, okay, then it would give me this. Okay, if I were to do upper bound as well, then it would still give me this. Okay, so if I have taken upper bound, I can be sure that the element previous to it will always be less than the element that I have searched for. So it will always be so LB, it will be UB, it will be greater than 4, and the element previous to it will be less than 4. Okay, so I can be sure if I just move one step back, then it would give me the range. It would give me the range less than my end time. Okay, so this is the reason that I have used upper bound. Okay, so if I had used lower bound, then you'd have to specifically check this condition. So my lower bound was here, right? So again, you have to check if this is less than or equal to my end time. Okay, it is not, then you have to move it back again. Okay, and if it were, okay, let's say if it were 4, then you would have handled that case differently. Okay, so that's why, to avoid this handling, you can of course do this, not an issue, but I found it more intuitive to use upper bound, because whatever upper bound is, if I just move an index backwards, then it will give me the range less than end time. Okay, I can be sure of that. Okay, so that's why I used upper bound. Okay, so if my upper bound is out of range, okay, let's say if it were here, okay, that means I have to take the entire score. Okay, let's say my end time was 7. Okay, so it will point me here, and I can just move an index back. Okay, so it will be here. Okay, so I need to consider the entire score. Okay, I would consider the entire score over here. Okay, of course, in this case, since I'm moving one index back, I can be sure my iterator won't be at my map.end, but I think I still handled this. Okay, no. Okay, so this is my end pointer. Okay, so why I'm doing the end, why I'm getting the end time first, because let's say if my range was 3 to 5, okay, first I would get this entire sum, right? First I would get the entire sum, and then I would subtract this, right? Whatever was behind my start time. Okay, that is why I'm handling the end time first. Okay, so let's check. Okay, I'm going to do a lower bound on mpp.begin to end for end time, and I'm just going to move an index back. So this is how you get the index in case of arrays. Okay, so this will give you the pointer. Okay, I'm sure you guys already know of this, but I'm just going to explain it for those who don't. So this will give you a pointer, this will give you an address. Okay, so if you just subtract the whatever you're searching for, its begin, then you would get the index. Okay, so in this case, okay, let's say I was searching for 5. Okay, and I got 5, so I can simply do a minus mpp.begin, and it would give me our index, which is 2. Okay, So why would I need index? To get the scores. Okay. Okay, so I've gotten the index. Okay, so if my JDX is less than 0, then I'm just going to return 0. Okay, so what does this mean? Write it over here. Okay, so there's only one element, which is 2. Okay, and my end is 1. Okay, so my JDX will point to this. Okay, and of course I'm going to decrement 1 because I'm using upper bound. Okay, so what will it so this index, if I subtract mpt.begin from this address, it will give me an index 0. Okay, if I move one step back, then it will give me a -1. Okay, so what does this mean? My end time does not exist. Okay, so let's say my scores were 1 2, my scores were 2 3. Okay, and my end time was, my query was from 1 to 1. Okay, so this does not exist, right? So that is why I'm going to return 0. Okay, yeah, I hope this makes sense. Okay, so if it is not, okay, so if my MPP of JDX is greater than n time, then again I'm going to return 0, else I'm just going to get the entire sum. Okay, so in this case, so these were my time, and let's say my corresponding array was my, okay, so these were the times and my corresponding scores were, say, 1. So corresponding score is 2 for this, and if I add 1, it will become 3. Let's say the score for this was 4, and if I add the previous, it will be 7. Okay, okay, so if my query was 1 2 3, then my JDX would initially point to here, then I'll move one step back. Okay, so my index is valid, and I'll get this entire, the sum till my end time. Okay, so I have this entire sum, which is 3. Okay, coming to the start time. Okay, so I'm going to do a lower bound for this. Okay, and if my st points to the st map.end, then my start time does not exist, and I'm just going to return 0. Okay, and similarly I'm going to get the index for the same. Okay, so if my index, okay, it is greater than n time, okay, then I'm just going to return 0 again. If not, if my idx is equals 0. Okay, so if it let's say in this case, okay, so I search for time 1. Okay, so it will point me here since I'm doing a lower bound. Okay, so this index is already 0, so there is no need to subtract any previous sum from it. Okay, so I'm just going to return sum. Okay, if that's not the case, then I'm just going to subtract from index -1. Okay, so finally I'm just going to return the sum. Okay, I hope this explanation was helpful, and yeah, I will see you guys in the next video.